This week at NASA.
3, 2, 1, 0. And liftoff of the Atlas V rocket with TDRS-K, broadening, enhancing, and improving the capability of space-based tracking.
The rocket carrying NASA's new Advanced Communications Satellite, TDRS-K, successfully lifted off Wednesday from the Cape Canaveral Air Force Station in Florida.
Roll program has begun. Body rates look good.
From its geosynchronous orbit, TDRS-K will have a wide enough view of our planet to pick up and relay signals from NASA's fleet of Earth-orbiting spacecraft, including the International Space Station and the Hubble Space Telescope. TDRS-K is the first of a new generation of comm satellites meant to meet the increased demands of NASA's growing fleet of research satellites.
Booster has throttled back, right on schedule.
TDRS-K is the 11th satellite in the TDRS series launched by NASA since it began building the spaceborne network in 1983. Two additional TDRS spacecraft will follow in 2014 and 2015. The Robotic Refueling mission wrapped up 4 of its 6 days of testing of robotic technology on the International Space Station. Engineers at the Goddard Space Flight Center and operators at the Johnson Space Center successfully maneuvered Dexter, the station's robotic arm, to its target, a fuel valve on a specially designed practice box. NASA developed tools precisely cut 3 separate wires and removed and safely stowed 2 unique caps in preparation for the main event, the transfer of simulated fuel. This would be a first-of-its-kind robotic fluid transfer on orbit. With RRM, NASA is proving technology that'll help us understand how we can one day use robots to refuel satellites in space, especially those that were never designed to be serviced. Additional tests of this technology will continue throughout the year. NASA engineers working on the nation's new space launch system have resurrected the world's most powerful rocket engine ever flown, the mighty F-1, and test-fired its gas generator on the Marshall Space Flight Center's test stand. What they learn will help engineers develop NASA's new heavy-lift rocket due to launch Orion and its astronauts into space.
If we understand how the gas generator works that was designed in the 50s and the 60s, how did it operate, what are the characteristics of that engine, then we have reduced the risk of understanding how can we then bring it into an advanced booster engine.
The F-1 powered the Saturn V rocket that sent Apollo astronauts to the moon. This 20-second test is one in a series pushing the F-1 gas generator to limits beyond Apollo-era tests. President Obama's proposal for a new national network for manufacturing innovation brought some 350 representatives from industry, academia, and economic development agencies to a NASA co-sponsored workshop in Huntsville. The Blueprint for Action public workshop was a forum at which the network's proposed design could be reviewed and refined. The Marshall Space Flight Center will be home to one of the network's regional components, the Institutes for Manufacturing Innovation.
Manufacturing innovation and advanced manufacturing technology is critical to NASA. It's critical to all of our missions. It's critical to our science missions. It's critical to our human spaceflight missions, our aeronautics missions, and our space technology mission directorate technology that we produce.
Marshall Center Director Patrick Scheuerman served as NASA's representative to the workshop's Interagency Working Group. NASA's Space Technology Mission Directorate leads the agency's participation in the nationwide Advanced Manufacturing Network. A NASA suborbital telescope has given scientists the first clear evidence of energy transfer from the sun's magnetic field to the solar atmosphere, or corona. This process, called solar braiding, has been theorized yet unobserved by researchers until the high-resolution coronal imager, HI-C, obtained highest-resolution images from a large, active region in the sun's corona. Launched from the White Sands Missile Range in New Mexico last July, the 464-pound, 10-foot-long HI-C telescope took 165 images during its roughly 10-minute flight. Initial image sequences were seen to demonstrate the evolution of the magnetic field and its repeated release of energy through activity seen on the Sun at temperatures ranging from 2 million to 4 million degrees. While the Mars rover Curiosity may be grabbing its share of headlines these days, another Red Planet rover is quietly embarking on its 10th year of exploration. Opportunity is smaller and doesn't carry the same high-tech tools as Curiosity, but since landing on Mars on January 25, 2004, it's made many notable discoveries, including the Red Planet's warmer and wetter past. Opportunity and its twin, Spirit, were only supposed to explore for 3 months, but both outlasted their original mission. Spirit lost communication with Earth in 2010, shortly after getting stuck in Martian sand. But Opportunity remains healthy and studying interesting rocks in a massive crater. Another NASA spacecraft, this one orbiting Mars, is providing new evidence of a wet underground environment that adds to an increasingly complex picture of the planet's early evolution. Researchers analyzing spectrometer data captured by the Mars Reconnaissance Orbiter (MRO) of the floor of McLaughlin crater think the 1.4-mile-deep crater once allowed underground water, which otherwise would have stayed hidden, to flow into the crater's interior. Layered, flat rocks found at the bottom of the crater contain carbonate and clay minerals that form in the presence of water. McLaughlin also lacks large inflow channels, and small channels originating within the crater wall end near a level that could have marked the surface of a lake. Launched in 2005, MRO and its 6 instruments have provided more high-resolution data about the Red Planet than all other Mars orbiters combined.
NASA scientists routinely use lasers to track the position of the Lunar Reconnaissance Orbiter's laser altimeter as it orbits the Moon. Recently, however, they also tried something a little different. In addition to tracking the instrument, they used the laser to send a picture of the famous Mona Lisa in the first demonstration of laser communication with a satellite at the Moon. To do this, the LRO team used the existing laser tracking signal sent by the Next Generation Satellite Laser Ranging Station at NASA's Goddard Space Flight Center. The image was divided into pixels, which were then sent to the spacecraft one at a time by retiming the regular tracking pulses. By delaying the tracking pulses by specific amounts, LRO scientists could use the difference between the expected arrival time and the actual arrival time to indicate the brightness of an individual pixel. Once the image was sent, scientists corrected for transmission errors caused by the Earth's atmosphere using common techniques used in CDs and DVDs. They also studied signal fluctuations due to Earth's atmosphere. The final image was verified when it was returned to Earth using LRO's radio telemetry system. This test, and the data obtained from it, sets the stage for future high data rate laser communication demonstrations that will be a central feature of NASA's next moon mission, the Lunar Atmosphere and Dust Environment Explorer. So, while lasers are currently being used to track NASA satellites, in the future they may also be used to communicate with them, sending not only data, but perhaps images that one day will be as famous as the Mona Lisa.
I do want to welcome all of you here for what I hope will be a very inspiring program.
NASA Administrator Charles Bolden kicked off a special commemoration at headquarters of the life and vision of Dr. Martin Luther King Jr. The MLK Day of Remembrance program featured musical selections, poetry, and speakers celebrating the continuing impact of Dr. King's work and philosophy.
People all over the country, including Dr. King, were very important in the civil rights movement.
The NASA headquarters chapter of Blacks in Government, BIG, sponsored the event.
Liftoff. We have liftoff with Apollo 14.
42 years ago, on January 31st, 1971, the Apollo 14 mission began with the launch of the Saturn V rocket from the Kennedy Space Center. Astronauts Alan Shepard, Stuart Roosa, and Edgar Mitchell manned NASA's third mission to land on the Moon.
It looks like you're about on the bottom step and on the surface. Not bad for an old man.
Shepard and Mitchell conducted 2 lunar EVAs and collected more material and scientific data than Apollo 11 and 12 combined. And famously, Commander Shepard swung the first golf club in space, sending 2 balls across the lunar frontier.
All
Apollo 14 touched down safely in the Pacific Ocean on February 9, 1971. This commemorative plaque was issued to the United States and the governments of 14 other countries to mark the signing of the Space Station Intergovernmental Agreement 15 years ago on January 29, 1998. The IGA is an element of the legal structure used to regulate the International Space Station and is an agreement between NASA, the Canadian Space Agency, the Japan Aerospace Exploration Agency, the Russian Federal Space Agency, and 11 member states of the European Space Agency. All right, here's your clue. She won more than $69,000 this month on the nationally syndicated TV game show Jeopardy. The answer, posed in the form of a question, who is Kristen Morgan? The engineer turned strategic analyst at the Marshall Space Flight Center leveraged her strong engineering and science background and several early college semesters as an art history major to cash in on the show she's watched regularly since childhood.
Who's Richard III?
Morgan thanked her colleagues in Marshall's Office of Strategic Analysis and Communications, who pitched in after hours to help prepare her.
She has a very impressive 5-day total of $69,098.
Morgan was top money winner on 5 Jeopardy episodes, qualifying her for the show's next Tournament of Champions. And that's This Week at NASA. For more on these and other stories, or to follow us on Google+, Flickr, and other social media, log on to www.nasa.gov.